Alright, in the first part of the Electron Cloud video, we talked about the overall organization of the Electron Cloud, how it has mean energy levels, sublevels, orbitals, and in each orbital can hold 2 electrons. And then I gave you a quick example of how those orbitals would fill up for the element boron. In this part, we're going to take a closer look at this because there are a few rules for how electrons fill up these electron clouds. I want to make sure that you understand these rules, and we're going to look at some elements that have more electrons in them than boron does. So the first thing I'm going to do is we're going to look at the organization of the electron cloud in a slightly different way. So here's what I'm going to do. I'm going to make a grid, and actually, let me see if I can, hold on one second here. Okay, that's better. So what I'm going to do is I'm going to make a grid, and across the top of the grid, I'm going to actually write the sublevels. So S, P, D, and F. And then down the sides, I'm going to put the energy levels, starting with the first, second, third, fourth, fifth, sixth, seventh. So at the first energy level, there's only one sublevel, and that's S. So what I'm going to do is I'm going to go ahead and just draw a line down like this, and I'm going to draw a line across like this, and then I'm going to draw another line down separating the S and the P. And so what I've done is I've represented the one S sublevel with a little box right here. Now at the second min energy level, you can have 2 sublevels. So I actually have to go over, and then I'm going to make a little P column like this. And you'll notice I'm stopping down there kind of at the 5th energy level, and you'll see why in a second. The third main energy level has all of them, S, P, D, and F. So for that, we have to go all the way over to D, and we draw a little column down like this. And then by the time you get to the 4th main energy level, you have encountered your first F orbital. So we've got to come over for the F, and then like this. Now, there are actually only, as far as we know, elements with 4F and 5F. So after that, we don't have to draw any more F orbitals. The S orbitals go all the way to 7. The P orbitals go all the way to 7. So I'm making my little diagram here. All the way across. There we go. And the D orbitals go all the way up to 6. Like that. There. Now, it's a little wavy because I'm drawing it on a computer, but what I've made here is a little grid, and this grid represents all of the possible sublevels that you can find in the electron cloud. Now at the bottom of this, as a reminder for myself, I'm going to write how many electrons each one of these sublevels can hold. Remember, the S sublevel, there's only one orbital, so it can only hold 2 electrons. But in the P sublevel, there's 3 orbitals, so it can hold 6. Each orbital can hold 2 electrons. The D sublevel has 5 orbitals, so it can hold 10 electrons, and the F sublevel has 7 orbitals, so it can hold up to 14. Now, the reason why I've drawn this is because as electrons fill into the electron cloud of an atom and they start picking what orbital they want to go into, they always want to go into the orbital that has the lowest amount of energy. So, they want to go into the orbital that they can exist in and have the lowest amount of energy possible. And while you might just think that it would just go in order 1s, 2s, 2p, 3s, 3p, it doesn't. This diagram helps you to remember the order of increasing energy per sublevel. So what I'm going to do here, go over and I'll grab my little blue color here. So the order in which they fill is on the diagonals of this grid. So if you can imagine diagonal arrows, an arrow going diagonally through all of the squares of this grid, then that might help you to remember the order in which these orbitals fill. by the way, if you want to copy this diagram down, you're more than welcome to do that, and then you can use it on any of your mastery quizzes or tests that you want to use it on. So if you look at this diagram, it looks like the first orbital, the first sublevel that's going to get electrons is 1s. And then the second sublevel that's going to get electrons is 2s. And then there's no more sublevels down here, so now we go to the next one. It looks like it's going to be 2p. And then the next one after that is 3s. Now at this point it's probably following the order that you would have predicted. But if you look, the next one to fill is going to be 3p. And then before 3d, sublevel 3d gets any electrons in it, the electron cloud is going to take electrons into sublevel 4s next. And then after 4s is full, then 3d will fill. And then 4p will fill. And then 5s will fill. So this diagram will help you to kind of predict how these electrons are going to fill. So let's look at an atom that has a slightly larger electron cloud than boron, which was our example in the first video. And let's look at let's look at iron. Iron's atomic number is 26, so iron has 26 electrons. So we have to try to figure out where in iron's electron cloud all those electrons live. And instead of drawing all the arrows like I did for the boron example, I'm going to show you another way to write out the configuration of a specific atom's electron cloud. So again, this is iron, so we're going to put Fe to start off. And then the first sublevel that has that receives electrons is 1s according to our grid. So I'm going to write 1s. And iron has 26 electrons, so 1s is going to fill, and so that 1s can hold 2 electrons total. So 1s, sublevel 1s with 2 electrons in it. So what this is saying is that the electron cloud of iron has a 1s sublevel, and that 1s sublevel has 2 electrons in it. Okay, so now after 1s is full, according to our diagram, the next sublevel to fill is 2s. And so I'm going to write 2s, and we have to account for 26 electrons, and we've only done 2 so far. All s sublevels can hold 2 electrons, so 2s2. So now, so far we've accounted for 4 of iron's 26 total electrons. And what I'm going to do is I'm going to keep using this diagram, and I'm just going to keep going until we've accounted for all 26 electrons. So all these little numbers that are up above the sublevels, we're going to keep going until that adds up to 26. So after 2s, the next one is 2p. So I'm going to write 2p, and then p can hold 6, so that's 2p6. And at this point, we're up to 10 electrons in the electron cloud, but again, we need 26, so we have to keep going. So we just did 2p, which is this box. After 2p, the diagonal arrow says we go to 3s. So we're going to go 3s, and then 2s. Sublevels can always hold up to 2 electrons. That gets us to 12, but we're not done yet. So after 3s, according to our diagonal arrows, we go to 3p. So 3p, and p's always can hold up to 6. Up to 6. Okay, so now we're at 10. And 6 plus 2 is 8, so now we're up to 18, and again, iron has 26 electrons, so we have to keep going until we get 26. So after 3p, which is right here, if we follow our arrow, the next one is 4s. So after 3p is 4s, and it can hold, all the s sublevels can hold 2 electrons, so it's 4s2. And again, what we're doing here is we're describing where all of the electrons are at in the electron cloud of iron. So this is a way of telling another chemist where all the electrons are inside of this atom. So now we've got 10 electrons here, and now we have 10 electrons here, which means we're at 20 electrons. So we only need to account for 6 more electrons. after 4s, which is right here, if we follow our diagonal, it stops here, so we have to go to the next one. After 4s, it's 3d right here. 3d. So 3d. Now, d sublevels can hold up to 10 electrons, but we don't need 10 electrons. We have 10, 20 electrons accounted for, and iron has 26 electrons. So we only need 6 more electrons. So there have to be 6 electrons in 3d. And that is the way that you write out where the electrons are at in the electron cloud of iron. So as long as you understand how the electron cloud is organized, as long as you understand the order in which the sublevels fill, you should be able to predict where all of the electrons are at inside of the electron cloud for any atom of any element. As always, if you have questions, you can ask in class. Thanks for watching.